Okay, today we talk about trapezoidal rule. I didn't talk much on the theory part. So it basically is to find out the integral. Let's say the integral of the graph is the area under curve. Before this, we just calculus to find the exact value, but right now we just want to find an estimation of it. So the area is similar like a trapezium. So this is so-called trapezoidal rule. Okay. So they have been in three things you're going to learn here. So because trapezium, there will be in terms of one segment, there will be in three things. So one is in single segment. So means I assume the whole thing as just one single thing. So two is multiple segment. This means that if you have more segment, the accuracy will be higher because the empty space here not included will be lesser. So multiple segment. And three is also multiple, but is uneven segment. Uneven segment. So it might be one is long and one is short. For example, one is like this, and the other one would be something like this. So their width are different. So I'm going to show you here in these three cases. So let's go ahead to find out the first segment. So I'm going to give you an Excel file, and this Excel file is how I help in solving numerical method. So instead of doing all those stuff that's very tedious, so I already included it into the Excel file. So you can just key in the value and you get the data and copy the step. Okay, so here it is. I've written this Excel file. So you can look into it. First, using this one is the single segment trapezoidal. So let's say we apply on this thing. If I want to find integral from 8 to 30, this is the question. It's 2000 long. That's 9.8 t dt. All right. So I'm going to solve it using the first one, which is the single segment. All right. So I just key in the value here. So as you can see, the formula, integrate the function is equal to b minus a, fa plus fb divided by 2. So I'm going to key in the value here. So my function now is 2000 ln, etc. I'm not going to type here. So I will find the lower limit. The lower limit here, which is 8. So I type in here 8. The upper limit, which is 30. So I type in 30. Okay. The F is what you have to input the value from the calculator. In this Excel file, you can see that the green color is what we need to input, where the yellow color is the answer we get. So you can input here. Instead of saying that, you can input the formula equal to 2000 times long is ln bracket 140000 divided by bracket 140000 minus 2100 times. This t here is the limit, so I can choose lower limit because it's fa, the function of putting the value 8. And then minus 9.8 times t again, which is this thing. And all right, yeah, I have one more bracket. 2000 times ln. Yeah, so bracket should be here, not outside here. Yes, okay, so I got it. Next, function b, then I substitute the value, which is 30 in this function. I put just substitute the t here to be 30, this one to be 30. equal to 0 there, I can just copy the formula here, copy, and I can paste it here. Then I just change my input, which is this one, and then t is this one. Okay, then we are good to go. Then I got this is my answer, which is 1, 1. Therefore, using the single segment, the answer is 11868.35. So it depends on your lecture one, how many significant figure. So that's how I got this. So let's go ahead, we can try right now using the second multiple segment. Okay, so we do the same question. 2 is the multiple segment. So let's say right now I'm using the segment which is 2 and equal to 2. Means I have 2 equal segments. They are same width to estimate this integral. So the formula itself is here, as you can see. Zoom in and B if you can't see it. All right. This is equal to B minus A over 2n FA plus because we have the segment here, let's say this is my A, lower limit, this is my B. So all the value in between here, which is here, the function here, which is this thing, A plus the I is the number times the H is the difference between B minus A, and divided by N, means the width here. So in summary, this multiple segment trapezoidal rule is the function of the first limit here plus the last limit here, which is FB, and the rest will be the point in between. The point in between. Because let's say I have more segments. Let's say I have 3 segments or 4 segments. So the point in between is going to put it here, in between this term represent. So in order to make your life easier, so you just need to key in the value. Then you can just copy. For example, if you want to solve it as is in your exam, you can copy this formula. Okay. Then you can copy this one, which equal to B minus A over N. And you can find out the term here. You can write here x1 equal to something, x2 equal to anything. And then you can write down all the steps here. And then you add them up together. And in the end, you can write down every term here. I'm going to share one by one. Okay, never mind. So the lower limit here, this one should be 2000. Well, this is just for your knowledge, but no effect to the whole calculation. The lower limit is 8. Upper limit, which is 30. This is 8, this is 30. And the interval, because I want 2 segments, so I press 2. So automatically, I can get my value, which is 11. So my first step, I can write in, okay, where H equal to B minus A over N. So I can say it's 30 minus 8 over 2 is equal to 11. So I can practice that in my paper. Right. And next, so it here says stop until it shows the upper limit. So here upper limit is 30, so it stopped at here x2. So means that this value we are not going to use it because we just use x1. Because from our graph, let's say from this is A, this is B, there's only one value here because of percent, which is here is 19. So the x2 here is 30, so we stop at here. We're not going to use x2, and we're not going to x3. I put that because of when we have more segments. Okay, so we just stop at 19. All right. Then we're going to key in the function here. The green color is what we need to input the value. So I can input the formula equal to. I can paste the formula from just now. Then I can change my input, which is my A is this one. A is this one. Alright, same again, I can copy the formula and I change the input. Instead of B7, I can now change, because this is x1 is the point in between, which is 19. I can choose 19 here. Okay, you see, f function of x1, so x1 here. Then here's x1, enter. Alright, now because we're not going f2, f3, so we go ahead to just fb the last term, is equal to enter. So I change my value, which is b. This is alright. So I can straight away get my answer here. Okay. Sometimes. Right. So I'll write down my step. So I can say my x1 is equal to 19. Straight away write that. Then I can write FA, or I can write FA is equal to 177.26678. Depends on, let's say I'm gonna say 4 digits here. If this is 5 significant figure, then it's gonna be 1, 2, 5, 7 like this. If it's 5 significant figure, depends on, because some lecture they want 6 digit, so it depends on up to your lecturer. If you want to make it up to like 3 decimal, I can go to here, right? So I right click this. I can click on format cell, go to a number, and then I increase it. 4 decimal. Same for this one. I get format cell. I'm gonna increase to 4 digit. So I don't need to worry about some mistake, careless mistake. So I can just copy here, it's equal to 2667. Then I copy in my paper, which is fx1, or simply f19, is equal to 484.7455. And fb, the upper limit 30, which is 901.640. Then, after I copy this, I should add up all together. Since I've written down the formula of the multiple segment, so I can just write b minus a, which is 3 minus a divided by 2 and 2. This is formula. I'm going to put this down. Bracket f8 177.2667 plus 2 times this thing 484.7455 plus this thing 901.6740. Okay, and then it's equal to the final answer, which is here 11266.3743. Yep, and that's it. Okay, this is how we easily, no need to scratch your head, but we can get very accurate answer. All right. Next thing is 3, which is using the third method, which is multiple segment as well, but with uneven the width, or uneven segment. So it's of the same question. Let's say the same question just now, learn something, et. So let's say I'm going to have uneven segments. So I can dissect this one as equal to, if integral, we can join like this. My function plus 19 to 30 ft dp. So here 8 to 19, which is 11, but here 19 to this one should be clear. Oh, it's the same. Maybe we could change it. Let's say I want base is 15. It's 15. This is 15. So here the length is, the width is 15. Here the width is 7. So we can write this step, and then we can further say this thing You can solve this one by single segment and solve this one by single segment. So we can go ahead to find out this single segment using single segment and this one single segment, 8 to 15. So we can go ahead to here, go back here using this one is a single segment. So from 8 going to 15. So all the value will change. Okay. Then I can have this one minus 7, 8, yep. And this is F8, yep. Then I got this one. So integral from 8 to 15 dt, the function, is equal to 1890.1794. Okay. And then we're going to add from 15 to 30. So again, we just change the value here from 15 to 30. And that's it. And you copy the answer here, plus 9483.438. And we add up together, we should get something, if not mistaken. I can calculate here, equal to 9483.4388 plus 1890.1094. Okay, so this is my answer, which is equal to 11373.6182. Also very close to our previous value, this one. So this is the method of solving it. So I'm going to make it a summary. So for trapezoidal rule, there'll be 3 methods or 3 ways your lecturer might ask you the question. One is using the single segment, okay, just one trapezium. 2 is multiple segment, which is n segment, maybe 2 or more. And 3, also multiple, but uneven segment. Uneven segment. So one is thin and one is thick, and etc. So therefore, in summary, there are 3 methods of solving it. So you can download the Excel file in the description below. And remember to like my video and share it out if you find it useful in helping your exam preparation. All right, see you.